Hi everyone, welcome to my new episode under trigonometry. What I'm going to talk about today is the four quadrants. Okay, so what we have here is the x-axis and the y-axis. This tells you that this is the x or y plane or the Cartesian plane. Now, what I'm going to do quickly is that from 0 degrees to 90 degrees is referred to be the first quadrant, okay? The first quadrant. Then from 90 degrees to 180 degrees, it's referred to be the second, okay? The second quadrant. And from 180 degrees to 270 degrees, this is referred to be the third quadrant, okay? And from 270 degrees to 360, the starting point, which is the 0 again, is referred to be the fourth quadrant. Okay, so I'm going to talk about the four quadrants. Okay, that means that my point is I'm going to apply the concept of SOHCAHTOA on all these quadrants and see how they behave. Okay, and see how the ratios behave. Okay, so I'm going to start with the first quadrant. Now, on the x or y plane, angles that are being measured from the x-axis and are elevating going anti-clockwise. These angles are referred to be positive angles, and angles measured from the x-axis going clockwise, these are referred to be negative angles. Now that said, what I'm going to do is, assuming that from the starting point to this point here, if this was our point O as a starting initial point, and this point was P. Now, let's just assume that from this point, it starts moving towards 90 degrees. And now, let's say that now the point P is somewhere there. Okay. If I was to get P in terms of coordinates, it's going to be x, what? Y, not so. Okay. So, as I was saying, that angles that are being measured from the x-axis going anti-clockwise, these are positive angles, okay? So, in other words, this is the angle I'm talking about, which has been formed after point P started moving, okay? Now, we know that in a circle like this, from the center to P, that will give us a radius, not so? Okay, so then, if P is sitting right there, for me to apply a SOHCAHTOA concept, I'm going to have to come up with an imaginary line for me to form a right-angled triangle. Remember, SOHCAHTOA only applies on right-angled triangles. So now that I have a right-angled triangle, we can see that, let me try to call this point here Q. Okay, and then this point as O. So you can see that from O to Q is actually in the respect of x-axis. So I'm going to call this side x, and from Q to P is in the respect of y-axis. And so I'm going to call this side y. Okay, I'm going to call this side as side y and this one as side x. And this side as hypotenuse as r, it being the radius. So now, allow me to apply the SOHCAHTOA concept on that first quadrant. Okay, so what I'm going to do is, I'm going to say, and the first quadrant, okay, we'll start with the side. So I'll say sine theta is equal to opposite over hypotenuse, okay? Then I'm going to say sine theta is equal to, what is my opposite? If this is the angle here, so my opposite is y. So I'm going to say y over hypotenuse is r. So I can see that y in this first quadrant is a positive, r is also positive, so my ratio happens to be positive, okay? Then, let me just keep that ratio. I'm going to keep it here to say sine theta is equal to y over r, okay, so that I can have some space here to use. Okay, Then let me now use cosine. So cos theta is equal to adjacent, okay, over hypotenuse, right? So I'm going to say cos theta is equal to adjacent. So this is our angle here. So adjacent is x. So x over hypotenuse, which is r. So I'm going to say cos theta is equal to x over r. Now I have the last one to handle. The last one is tangent. So I'm going to say tan theta is equal to opposite over adjacent, right? So I'm going to say tan theta is equal to, now this is our theta here, so opposite is y, adjacent is x. Okay, so I'm going to write that here. I'm going to say tan theta is equal to y over x. All right. Now, in conclusion here, what you can see now is that all these ratios in the first quadrant happens to be positives. Okay. Why do I say they are positive ratios? You can see that on the, let me just use the diagram here quickly. If we have the x or y plane, so what will happen is that numbers from 0 here going in that direction are positives, and numbers in the x-axis, right? And numbers from 0 going in that direction are also positive. So meaning y in the first quadrant is a positive, and x in the first quadrant is also positive. That's what I mean when I say we can all see that y is a positive, x is a positive, and r is also a positive, because r must always be positive. Okay? So in other words, we can all now conclude that all the many trigonometric ratios are positive in the first quadrant. Okay? So what I'm going to do is I'm going to wrap that, and I'm going to say in the first quadrant, all of them, all ratios are what? Are positive. Okay, now let's take the same diagram, the same right angle to the second quadrant. So I'm going to have my point P right there, okay? I'm going to have my point P right there. So remember, our angle is coming from the x-axis, so that will be our angle there, okay? Now, this, I'm going to make the imaginary line again for me to have the right angle triangle. So that becomes the radius, this becomes y, and from this point here, let me call this point Q. So from Q to O is still in the respect of x-axis. Okay, so again, what I'm going to do is, I'm going to apply, okay, I'm going to apply let's say the second quadrant now, okay, it's the second quadrant. I'm going to apply secateurs of this one in the second quadrant, meaning angles from 90 degrees to 180. I'm going to start with sine. Sine theta is equal to opposite over hypotenuse. So I'm going to say sine theta is equal to, just give us a space, sine theta is equal to opposite to this angle is y, okay, y over, okay. Now hypotenuse is r, okay. So I'm going to write that down. I'm going to say sine theta is equal to y over r. So I can see that sine is the ratio is a positive, okay, because y, okay, y is in a positive, okay, and r is a positive. Then I'm going to move on to cos. So I'm going to say cos theta is equal to adjacent over hypotenuse. Okay. Now I'm going to say cos theta is equal to adjacent, okay, to this angle. Adjacent is x, and we all know that on the left side, okay, 0 going this side on the x-axis are negative numbers. So meaning that we have a negative x over hypotenuse, which is r. So all in all, we can say that cos theta is equal to negative x over r. So I'm going to write that here. I'm going to say cos theta is equal to negative x over r. Okay, then I'm going to have to do the last one. Okay, I'm going to do the last one. So let's do tangent. Tan theta is equal to opposite over adjacent, right? So what I'm going to do is, I'm going to say tan theta is equal to, what is opposite from the angle here? Opposite is y is positive, over adjacent is negative x. So therefore I'm going to say tan theta is equal to negative y over x. I'm going to write it here. So I'm going to say tan theta is equal to negative y over x. Okay, so now to conclude with the second quadrant, okay, to conclude with the second quadrant, you can see that out of the three many trigonometrical ratios, sine has a positive, okay, cos has a negative ratio, tangent has a negative ratio. So what we can say is that every time you are calculating angles between 90 degrees to 180 degrees, when you use sine, it will give you a positive, and when you use cos and tangent, it will give you a negative. So in conclusion, what we are saying is that in the second quadrant, it's only sine that turns out to be positive. Okay. Now allow me to progress to the third quadrant. So this time we're doing the third quadrant. Okay. So let's have that. Let's have our point P here. Our point P here. I'm gonna have my imaginary line again, like that. So I'm gonna call this point Q. Okay. So we still know this still remains the x, and this x is a negative. Okay. So this one is radius, and this one is in the respect of y. And this time the y is also a negative. Okay. So allow me to now apply the SOHCAHTOA. Don't forget that the angle is still being formed from the x-axis. So I'm going to say, let me see if the red will come out fine. I'm going to say sine theta, I'm starting with sine again, is equal to opposite over hypotenuse, right? So I'm going to say sine theta is equal to, opposite to the angle is negative y over hypotenuse, which is r, right? So I'm going to write it here. I'm going to say sine theta, okay, is equal to negative y over r. Okay. So let's go to the other one. Let's go to cos. So I'm going to say cos theta is equal to adjacent over hypotenuse. Okay. So I'm going to say cos theta is equal to adjacent to this angle is negative x over, okay, hypotenuse is r. Okay, so I can write that here to say cos theta is equal to negative x over r. Okay, so let me do the last one. Okay, so far the two ratios are negative. Let me do the last one, which is the tangent. So I'll say tan theta is equal to opposite over adjacent. So I'm going to say tan theta is equal to opposite to the angle here is negative y over adjacent to the angle is negative x. So I'm going to say tan theta is equal to the negative and the negative will cancel. So I'm going to have y over x, which happens to be a positive now. The ratio is now a positive. So tan theta is equal to y over x. So in this case, we can see that after applying, in the third quadrant, after applying the trigonometrical ratios or SOHCAHTOA, sine came out negative, cos came out negative, and tangent, but tangent came out positive. So what we are now saying in conclusion is that in the third quadrant, angles falling between 180 and 3 and 270 are positive when we apply tan. Okay? When we apply tan. So meaning that tan is the only ratio, or trigonometric ratio, that has turned out to be positive. Okay? And that's why we are putting it there. Remember that in the first quadrant, all the ratios were positive. In the second quadrant, only sine was a positive. Now in the third quadrant, only tan is a positive. Let's try the last quadrant. Let's try the last quadrant. Okay, so this time is now the fourth quadrant. So we're looking at the fourth quadrant. So the fourth quadrant will have our center still as O. Then I'm going to have my point here as P. So I know that the angle that has been formed is that one. So I'm going to have, let me just draw that better so that it's a bit bigger. So I'm going to have my P there, okay, my P there. So I'm going to have my imaginary line as right angle. So this is X, this is going to be Y, that is going to be R, knowing that this is the angle that I have formed from the x-axis. So what I'm going to do is I'm going to apply, as usual, the SOHCAHTOA. So I'm going to start with sine again. Sine theta is equal to opposite over hypotenuse, right? So I'm going to say sine theta is equal to, now opposite to the angle is y. This time y is still a negative in the fourth quadrant. So negative y over hypotenuse, which is r. So I'm going to write that sine theta is equal to negative y over r. Okay, let's go to cosine. Let's go to cosine. So with cosine, I'm going to say cos theta is equal to, okay, adjacent over hypotenuse, right? So I'm going to say cos theta is equal to adjacent to the angle is x, okay, over hypotenuse is r. So I'm going to say, okay, so let me use ray. So let's use tan. Tan theta is equal to opposite over adjacent, right? So I'm going to say tan theta is equal to opposite is negative y. Is negative y over adjacent is x. Okay, so meaning that with tan theta it's equal to negative y over x. Okay, so in conclusion, the fourth quadrant we can see by checking the ratios after applying SOHCAHTOA. Sine turns out to be negative, cos is a positive, tangent is a negative. So what we can say is that here it's the cos that is working out positive. Okay, now what this means in conclusion is that in the first quadrant, if you apply the SOHCAHTOA, all the many three trigonometric ratios will always turn out positive. What I'm trying to say here is that if you were to punch any angle from 0 degrees to 90 degrees on a calculator, regardless of the ratio you use, whether sine, whether cos, whether tan, the answer will be a positive. And from 90 degrees to 180 degrees, what I'm saying is, from this guy, what I'm saying is that if you punch any angle from 90 degrees to 180, that means maybe 110 degrees, maybe 150 degrees, 160 degrees, 175 degrees, using sine. If you punch any angle from 90 degrees to 180 using sine, the answer will turn out to be positive. But if you use tan and cos in angles between 90 and 180 degrees, your answer turns out negative. And from the third quadrant, from 180 degrees to 270 degrees, any angle falling between 180 and 270 degrees, if you punch it using tan on your calculator, the answer turns out to be positive. But if you punch any angle falling between 180 and 270 degrees using the sine and the cosine, you will get a negative. Again, on the fourth quadrant, if you punch any angle on your calculator using cos, angles falling from 270 degrees to 360 degrees, when you punch any angle, and I mean any angle from 270 degrees to 360 degrees using cos, the answer turns out to be positive. Okay, so that is what it means, and that's what you have to understand about the quadrants. Okay, I hope you have understood the concept under the quadrants, the fourth quadrant, the first, second, third, and the fourth quadrant with this diagram that I have used. This will help you understand angles between 90 degrees to 360 degrees. Okay, now if you have any questions, all you can do is leave your question in the comment section. And if you like the video, you've enjoyed the session, please like the video. And in this time of COVID-19, share the video with your friends. I'm sure you have a lot of friends out there who are also staying home, self-quarantine. So if you share the video, it might be of good use. Thanks for watching. And if you're new to the channel, please don't forget to subscribe. Thank you.